In the network shown, switch K is closed at T is equal to 0. In the network shown, switch K is closed at T is equal to 0 with the capacitor uncharged. With the capacitor uncharged. Find the values for I of 0 plus di 0 plus divided by dt at t is equal to 0 plus
I of 0 plus
I of 0 plus di 0 plus by dt at t is equal to 0 plus, and also find d square I of 0 plus divided by dt square.
So the
So
capacitor is charged.
capacitor is with
Uncharged.
the capacitor is uncharged. I will repeat. In the network shown, switch K is closed at t is equal to 0 with the capacitor uncharged. Find the values for I of 0 plus di 0 plus by dt at t is equal to 0 plus, and also find d square I of 0 plus by dt square. Asked in one exam, 10 marks question. So this is the circuit. Resistor, and here there will be a capacitor, and then this is the circuit, and this is where 10 volt, and this is the switch, it is K, and here resistance is 2 ohm, and this is the 1 Henry, and this is our half farad. So now assume the loop current as I of t. So at t is equal to 0 minus, what is the switch position? At t is equal to 0 minus opened. So at t is equal to 0 minus, what is the switch position? Switch is closed at t is equal to 0. That means at t is equal to 0 minus switch has opened. Then what is the current I of 0 minus?
0 amps.
0 amps. I of 0 minus will be 0 amps. So at t is equal to 0 plus. At t is equal to 0 plus. Switch has closed. No, here. When the switch has closed here, resistor is there. So inductor will be acted as a short open circuit. And here capacitor will be acted as a short circuit. And this is a 2 ohm. And this is our 10 volt. And this is our I of 0 plus. Then what is I of 0 plus?
0.
0 amps. 0 amps. Net at t greater than equal to 0, what is the circuit you write? That is this is your 10 volt voltage source, switch has closed, right? Resistor is there, capacitor is there, and inductor is there, that you have to write. So this is your resistor is 2 ohm, and this is your 1 Henry, and this is your half farad, and this is the current, that is I of t. Now apply KVL for this circuit. Apply KVL. When apply the KVL, we can write it as a 2 into IT plus 1 into DIT divided by DT plus 1 by C integral of I of t into dt is equal to 10. Call this equation as a 1. Now this is, we can write it as a 2 into I of t plus 1 into DIT divided by 2 into I of t plus this is di of t divided by dt plus this is
Amps per second.
the voltage across the capacitor.
Sir, is the answer 10 amps per second?
Wait till do now. At t is equal to 0 plus, again at t is equal to 0 plus, this becomes 2 into I of 0 plus plus di 0 plus divided by dt plus Vc 0 plus is equal to 10. 2 into I of 0 plus is 0 ohms plus di 0 plus divided by dt. What is the voltage across the capacitor immediately after closing the switch?
0.
0, because you shorted, when you measure the shorted point, you will get a 0. So this is 10. So therefore this is di 0 plus divided by dt is equal to 10 amps per second. Differentiate equation 1 with respect to t.
Sir, d square I by dt square is equal to minus 20 amps per second square.
Yes, correct. Differentiate equation 1. Differentiate equation 1 with respect to t. So we'll get 2 into dit divided by dt plus d square I of t divided by dt square plus 1 by c I of t is equal to 0. At t is equal to 0 plus, this becomes 2 into di 0 plus by dt plus d square I of 0 plus divided by dt square plus 1 by c I of 0 plus is equal to 0. Substitute the value. This is 2 into 10 plus d square I of 0 plus divided by dt square. I of 0 plus is 0, therefore this becomes 0. Therefore d square I of 0 plus by dt square is equal to minus 20 amps per second square. Understood this problem?
Yes, sir.
Okay, shall I go to the next problem? Any doubts in this
1
problem?
minute. Sir, can you scroll up a little, sir? First part.
Down up.
You have to go up, sir. Up. Not like that, sir. Yes. A bit more, sir. 1 second to the question part. Okay, sir. Thank you, sir.
Or and go to the next problem.
Yes, sir.
Note on next question. In the given circuit, switch K is closed. Switch K is closed at time t is equal to 0. Switch K is closed at time t is equal to 0. Find the values of I1, I2, di1 by dt, di2 by dt, d square I1 by dt square, d square I2 divided by dt square at t is equal to 0 plus. So this is the circuit for this problem. Note on this circuit, and here there will be a one voltage source and here there will be a resistance and then inductance. This is your 10 volt, and this is the switch key, 2 microfarad, 10 ohm, and this is 1 Henry, and this is your 10 ohm.
Sir, where is I1, I2, sir?
You have to assume. He asked to find out I1, I2, di1 by dt, di2 by dt, d square I1 by dt square, d square I2 by dt square at t is equal to 0 plus. All you have to find out t is equal to 0 plus only. At t is equal to 0 plus, what is the circuit? So switch has closed. Capacitor will be acts as a short circuit. Then resistor is there, that you write. And here resistor is there. Immediately after closing the switch, inductor will be acts as an open circuit. So this is your 10 volt, and this is the resistance is 10 ohm, and this resistance is a 10 ohm. This is the one loop. Assume the one loop current I1 of t, and this is another loop current. Assume another loop current I2 t. So here, what is a I1 0 plus? I1 0 plus is equal to, this is I2 0 plus is 0 because it's open. Therefore, I1 is equal to 10 divided by 10, that is equal to 1 amp. And I2 0 plus is, it's an open circuit, therefore it will be 0 amps. Now t greater than or equal to 0, so write a circuit diagram. At t greater than or equal to 0, what is the circuit you write? Here there will be a capacitor, that you write, one resistor is there, that you write, and here there will be a resistor and then inductor. So this is your 10 volt, this is 2 microfarad, and this is 10 ohm, and this is 10 ohm, and this is your 1 Henry. So this is your I1 of t, and this is your I2 t. So apply the KVL for the loop 1. Apply KVL for loop 1. Then we can write it as 1 by C integral of I1 of t into dt plus 10 into I1 of t minus I2 t minus 10 is equal to 0. This 1 by C integral of I1 of t into dt plus 10 I1 of t minus 10 I2 t is equal to 10. Call this equation as a 1. Differentiate equation 1 with respect to t. So we get 1 by C I1 of t plus 10 into di1 of t divided by dt minus 10 into di2 divided by dt is equal to 0. At t is equal to 0 plus, this is 1 by C I1 0 plus 10 into di1 0 plus divided by dt minus 10 into di2 0 plus divided by dt is equal to 0. Substitute a value. So 1 by C is 2 microfarad, 2 into 10 to the power of minus 6. I1 0 plus is 1 amp plus 10 into dI1 0 plus divided by dt minus 10 into dI2 0 plus divided by dt is equal to 0. So this you can call this equation as a second equation. Next you apply KVL for the loop 2. Apply KVL for loop 2. When apply the KVL for the loop 2, we can write it as 10 into I2t plus 1 into di2t divided by dt plus 10 into I2t minus 10 into I1 of t is equal to 0. If further you simplify this is, we can write it as 20 into I2t plus di2t by dt minus 10 I1 of t is equal to 0. So call this equation as a 3. At t is equal to 0 plus, at t is equal to 0 plus, this becomes 20 into I2 0 plus plus di2 0 plus divided by dt minus 10 I1 of 0 plus is equal to 0. So this is 20 into I2 0 plus is 0 amps plus di2 0 plus divided by dt minus 10 I1 0 plus is 1 amps, that is equal to 0. Then di2 0 plus by dt is equal to 10 amps per second. You can call this equation as a 4. Next, use equation 4. Use equation 4 in 2. In 2, we get then we'll get it is, so 1 by 2 into 10 to the power of minus 6 plus 10 into di1 0 plus divided by dt minus 10 into 10 is equal to 0.
I will get minus 4.999 into 10 power 5.
How much it is di? Minus 49,990
990.
amps per second. Minus 49,990 amps per second.
What we have to get again, sir?
Differentiate equation 3. Hmm?
Yes, sir.
Differentiate equation 3 with respect to t. Differentiate equation 3 with respect to t, we get 20 into di2 divided by dt plus d square i2t divided by dt square minus 10 di1 of t divided by dt is equal to 0. At t is equal to 0 plus, this is 20 into di2 0 plus by dt plus, this is d square i2 0 plus divided by dt square minus 10 into di1 0 plus divided by dt is equal to 0. Substitute all the values and find out what is the dA square I2 0 plus d square. In this expression, find out what is the d square I2 0 plus divided by dt square.
Minus 50,090.
Minus
50190
190, na? 50190
amps per second.
amps per second square. Next, you want to find out
Sir,
di1
1900, sir.
huh?
1900, 501900.
00, no? Okay. Next, di1 0 plus, you have to find out d square I1 0 plus, right? For
Yes, sir.
this, okay, take a second equation. Differentiate equation 2, okay, with respect to t, and find out what is the find out
Sir, it is minus 500100, sir.
d square I1 0 plus divided by dt square is equal to minus 5. Repeat once again, minus
Sir, I
5.
was talking about I2, sir. I2, d square I2 by dt square.
Minus 501900, no?
Illa, sir, minus 500100.
All of you got the same answer?
Minus 500100.
Minus 500
100.
1 again 00, na?
Yes, sir.
All of you got this answer?
Yes, sir.
Okay, d square I1 0 plus by dt square.
I'm getting the same answer, sir.
Same answer for this also?
Yes, sir.
Okay. All of you got this answer only?
Yes, sir.
Okay, note on the next question.
1 minute, sir.
Just a minute.
Hmm.
Sir, I am getting a different answer, sir.
What is the answer?
It's a very large number, sir.
No, approximately this should get
Yes, sir. It's 500100.
correct.
Yes, sir.
Okay, then you should verify. Okay, take the next problem. Next question you note down. Explain the behavior of RLC elements at the time of switching at t is equal to 0 both at t is equal to 0 plus and t is equal to infinity I will repeat the question. Explain the behavior of RLC elements at the time of switching at t is equal to 0, both at t is equal to 0 plus and t is equal to infinity. Asked in one exam for 6 marks. What I gave them starting table at t is equal to 0, t is equal to infinity for the different elements that you have to write and explain. And one more exam, they asked a question like this. Note on the question. What is initial and final condition? What is initial and final condition?
Another question, sir. This is
Yes, another question. What is initial and final condition? Explain the behavior of R, L and C. Explain the behavior of R, L and C for the initial condition. This was also asked in one exam for 6 marks. Write what is initial and final condition, and you have to explain only behavior of initial condition only, not at t is equal to infinity. That you have to explain in the table only. Explain. Next question. Now to the next question. In the circuit shown, switch K is closed. Switch K is closed at T is equal to 0. In the circuit shown, switch K is closed at T is equal to 0. Find VA0 minus. Find VA0 minus and VA0 plus. VA0 plus.
Sir, what is the answer for previous two questions, sir? Table only, sir.
That table only, with the explanation I gave, no, that you have to write. Starting only I gave, no. It's
Yes, sir.
table explanation that you have to write for the previous two questions. I am not handling fifth sem, third sem. Nan third ಇದು ಫಿಫ್ತ್ ಸೆಮ್ ಇದೆ ಇದು 18 ಇಸಿ ಇದು ಲ್ಯಾಬ್ದು ಲತಾ ಮೇಡಮ್ ಇಲ್ವಾ ಹೌದಾ ಅಟೆಂಡೆನ್ಸ್ ಅಲ್ಲಿ ಮೋಸ್ಟ್ಲಿ ಯಾರು ಇಲ್ಲ ಅನ್ಸುತ್ತೆ ಒಂದು ನಿಮಿಷ ಆಮೇಲೆ ಕೊಡ್ತೀನಿ ಬಿಡಿ ಪರ್ಮಿಷನ್ ಕೇಳ್ಬಿಟ್ಟು ಅಲ್ಲೇ ಅಟೆಂಡೆನ್ಸ್ ಅಲ್ಲಿದೆ ಮೇಲೆ ಹಾಂ ಓಕೆ ಯಾರು ಇಲ್ಲ ನಮ್ದೇನು ಆಮೇಲೆ ಕೇಳ್ಬಿಟ್ಟು ಕೊಡ್ತೀನಿ ಬಿಡಿ ಓಕೆ okay, next or or they can ask the question like this. Note down. In the circuit shown, a steady state is reached. A steady state is reached with switch K open. With switch K open. At T is equal to 0, the switch is closed. The switch is closed. For element values given, determine the values of VA0 minus and VA0 plus Note on this circuit. Now this is the circuit diagram. Note on this diagram. This is your 5 volt and this is the switch, that is a K, and this is your 10 ohm and this is 2 Henry and this is your 20 ohm, and this is 10 ohm, and this is also 10 ohm, and this is the node, it is VA. At T is equal to 0 minus, the switch is, what is the switch condition?
Open, sir.
Huh? The
It's
switch is
open.
open. The circuit diagram. The circuit diagram is as shown. Write a circuit diagram. So we can write a circuit diagram like this. Switch has open now. That is open switch here, and there will be a resistor here, and here there will be a one voltage source, and it is connected like this. Here there will be a resistor is there. Then it is an inductor, and from here to here, when the resistance is there, that it is connected here. So
Sir,
this
but
is your
inductor will be like shorted, no, sir.
huh?
Inductor we can
Inductor will be
represent as
shorted
short
or
circuit.
given as current. Current.
Okay, what is given in the circuit shown, a steady state is reached with switch K opened.
Open,
Yes,
Switch
sir.
sir.
is opened.
Yes.
So therefore, this is inductor is short. Current will be flow in this circuit. This is it is shorted and current will be flowing in this. This is and current will be flowing is IL 0 minus. So this is your 5 volt and this is the here 10 ohm and it is 20 ohm and it is 10 ohm 10 ohm. Okay, you can node, you can take this node as a VB, you can take. Is given node, this node as a VA and this node you can take as a VB. Then what is the IL0 minus, what is the current here? This is a voltage source, no? One current will be flowing like this and it is opened. So you can neglect this. Another current is flowing this branch. Okay. And this sum of the current is the IL0 minus, right? So here, see there, this is the voltage source now here. The one current will be flowing like this, another current will be flowing this, and these two is combined and it is
2 by
flowing
3
here.
amps, sir. 2 by 3 ampere.
Yes, yes.
0.66.
So this current will be flowing, this sum of this current. So therefore we can write it as IL0 minus is equal to, so 30 divided by 5, V by R, V by R. So V by R is Okay, IL0 minus is equal to IL0 minus is equal to
0.666
V
amps.
by R 5 by 30 plus 5 by 10 5 by 10. How much?
0.666, sir.
0.66
0.666 amps.
66 amps.
2
This
by
is
3.
IL 2 by 3. Okay, this is amps. He asked to find out VA0 minus. What is a VA0 minus? Voltage across this point and this. The voltage. No, here. All right, I'll mark here. VA0 minus is this. Right now, this is the VA0 voltage from across the point from this and ground point. That means you can take voltage across 20 ohm. You can take the voltage.
1.66, sir.
Okay, voltage across 20 ohm.
Sorry, 3.33, sir. I mean 3.33.
Okay, wait up. There other guys are listening now, yeah. The voltage across the 20 ohm. What is the voltage across the 20 ohm here? Now, see there here, 10 ohm, 20 ohm, it is connected to voltage source, 5 volts. 10 ohm is also connected to 5 volt. You can write separately. Earlier, how you doing the source transformer, you can write like this. Now, this is 10 ohm, 20 ohm are connected in series with the voltage source 5. Therefore, voltage across 20 ohm means you can take this voltage, you can apply voltage division formula. So that is VA 0 minus is equal to, we can write like this, VA. So VA 0 minus is equal to, so this is 20 into 5, 20 into 5 divided by 10 plus 20. How much it is?
3.33.
0.33, sir.
3.33, na?
Yes, sir.
3.33 volt. Okay. Uh, what is the IL0 plus?
IL0 plus is equal to IL0 minus, sir.
Yes. So you can write one sentence here. Since the current through, write one sentence. Since current through inductor cannot change instantaneously, since the current through inductor cannot change instantaneously, therefore IL0 plus is equal to IL0 minus is equal to 0.666 amps. Okay. Now at T is equal to 0 plus, write a circuit. At T is equal to 0 plus. At T is equal to 0 plus, write a circuit. At T is equal to 0 plus, what is the circuit? The
Which will be closed.
switch is closed. Okay, write a switch is closed and resistance is there. And steady state has been reached no earlier. Therefore, in the inductor, the same current will flow. And here it is the resistance, it is there. So this is our 10 ohm and this is a 20 ohm. And here it is 10 ohm. And here it is 10 ohm. This is our 5 volt. What is the current will be flowing here? 0.66 amps. 0.666 amps. So this you can take as a VA0 plus. Okay. And this you can take as a VB0 plus. Or we can take a VA, VB, then apply a T is equal to 0 plus. Okay. Then you apply KCL at node A, right? And apply KCL at node B, write a equation. From this, find out what is the VA0 plus. Solve this problem. Apply KCL at node A, VA0 plus. Apply KCL at node VB0 plus. Solve those two equations. In that equation, find out what is the VA0 plus. Find out and tell me the answer.
Sir, VA I am getting. Excuse me, sir.
How much?
1.904, sir.
1.904. 40
And
by
I'm
21,
getting
how much? Okay.
Same,
Correct.
sir. 40 by 20.
40 by 21. 1.904, no?
Yes, sir.
Then correct. So all of you got the same answer? The same. Apply KCL at node A. Apply KCL at node VA0 plus. So we can write it as VA0 plus minus 5 divided by 10 plus VA0 plus divided by 10 plus VA0 plus minus VB0 plus divided by 20 is equal to 0. So VA0 plus, take the common factor. This is VA0 plus minus 1 by 20 VB0 plus is equal to 5 by 10. Okay, you simplify. What is the value for this? 1 by 10 is 0.1, 0.1, 0.2, 0.2,
0.25, sir.
0.25,
Yes, sir.
0.25 VA0 plus minus 0.05 VB0 plus is equal to 0.5. Call this equation as a 1. Next, KCL at, apply KCL at node VB plus. Then it is VB0 plus minus VA0 plus divided by 20. Okay, current is leaving the node 0.666 plus VB0 plus minus 5 divided by 10 is equal to 0. Next it is minus 1 by 20, 0.05 VA0 plus 1 by 20 plus 1 by 10. This is VB0 plus is equal to minus 0.666 minus 0.5 VA0 plus this is how much it is? 0.1.
0.15.
0.1, 1 by 20,
0.15, sir.
0.15,
Yes, sir.
1 pi VB0 plus is equal to minus 0.66. Call this equation 2. In this expression, solve what is VA0 plus. How much is 1.1 point?
But we have to subtract 5 by 10 also, no, sir.
5 by 10 you have to subtract.
Yes, sir, from 0.666.
Why?
Because you have taken, no, sir, VB0 plus minus 5 by 10. But you have not considered that 5 by 10, sir.
Okay. Here only you have to consider.
Plus,
This is VA0
Sir,
plus,
in the
this is 1 by 20
RHS,
plus
in the
2.
RHS, you just add
plus
Ah,
0.5.
0.6.
plus 5 by 10 now. Here 5 by 10
Yes,
is
sir.
0.2.
0.5.
0.5, sir.
0.5. Here 0.5 you have to add. 0.5 you have to add here. 5 by 10 I not consider here. Forgotten to consider. And then what is the value here? How much now?
Minus
Point
0.616.
166, sir. Minus
Point?
0.166.
166, yeah?
6.
Okay. V is 0 plus. Solve these equations. How much? What is the value? V is 0 plus value.
1.9057, sir.
1.5
9057.
volt. This is the answer. Okay, is it clear? Any doubts? Okay. So I will take only another one class, then I will close this chapter. Then we'll move to the last chapter only, that remaining only one chapter that I will start. Okay.